Transport plugins and transport QoS policies. Connext DDS uses a plugin architecture to access the underlying network technologies that are supported. So fundamentally, almost any network technology can be used by DDS. It doesn't have to be IP-based, although by default, Connext has some built-in plugins that are ready to be used out of the box to work on UDP-v4, UDP-v6, that's UDP protocol on IPv4, IPv6 networks, as well as shared memory, which is a technology that's used between processes on the same host. So the default plugins are ready to use, and they can be configured through different QoS settings. But in addition to the built-in plugins, there are also some other plugins that are not built in. Built-in means that they're a part of the library that you link with. We also have other plugins that are supported as external linked or dynamically loaded plugins. They include ones for TCP and secure TCP called TLS. And a couple of optional plugins, real-time WAN and a limited bandwidth to talk over networks that have a very constrained links or very constrained bandwidth. So real-time WAN and limited bandwidth are optional components that you may or may not have with your installation of Connext DDS. Depends on what you're licensed for. Now, because it's a plugin technology, you can actually create your own plugins with or without support from RTI. We know of customers who have created plugins to talk over a PCIe bus, over a VME backplane, to talk over serial connections, either a serial line or serial interface to radio. So these are all plugins that can be used by Connext DDS, and they can be used simultaneously. You can have multiple plugins installed, and DDS can be configured to use all of them at the same time. So let's talk about multiple networks. Now, these could be different network technologies, or they could be the same network technology, just multiple interfaces. For example, if you're using the IP network, you may have multiple network cards. And your host may be assigned different network addresses. Even on my laptop, I have both Wi-Fi and a wired Ethernet connection, and they will show up as two different IP addresses for my host. Connext DDS will actually by default use all these transports at the same time, especially IP. By default, DDS is going to query the IP layer, tell me about all the interfaces, and then automatically start using them. When they're using them, when DDS uses this, by default, DDS will send data on all these networks and receive data on all these networks. So if you, as a data writer, send one piece of data, DDS will actually send a copy on every network that it's connected to. And then if a subscriber is connected to all those networks or the same networks, the subscribing application will actually receive duplicate copies, but your code will only see one because we know that we got a duplicate copy of the data. This is what happens by default. Now, you could configure it not to do that. You could configure DDS to send some data over one network and some data over another network. But by default, DDS is actually robust to the failure of any one network. For example, here again, we have two network interfaces and data was sent over both network interfaces. If one of the network interfaces fails, okay, and you send data, as long as the other network is still connected, you'll still get your data, even though one of the networks actually got cut. Duplicate data received by DDS, we will know it's duplicate, and we will filter the duplicate data out. Whichever data we get first, you'll get, and then any copies of that data that we get later on will not be presented to you. So the transport built-in QoS policy is what you use to enable, to tell DDS which of the built-in transports you want to use, and it's configured by the mask parameter. By default, UDP over IPv4 as well as shared memory are enabled, but you could also use this mask to enable UDP-v6 as well as the optional UDP-v4 WAN plugin transport. To configure the properties of each transport, use a different set of properties, or a QoS, and they are the UDP-v4 property, the UDP-v6 property, shared memory property, and the real-time WAN, or the UDP-v4 WAN property. And with these properties, you can configure things such as the buffer sizes, sizes of the send and receive sockets, or the size of the buffer shared memory that's allocated, which network interfaces you want the plugin to use, and this is specific to IP interfaces. You may want to set the TTL for multicast traffic. So if you're using multicast and you're sending multicast, you may want to modify the time to live for the multicast so that that packet can exist and be routed beyond the local subnet, which is the default. If you're behind a NAT router, you may want to set a public address so that other people can contact you. They may not be able to send a packet to your local network interface, but if you know what your public address is, then somebody can send data to your public interface or public address, which will be routed by the NAT, or network address translation router, back to you. And of course, there are lots of other properties that you might want to configure on these transports. Now, for non-built-in, so without, if it's not built in, if it's not part of the library, you may need to install these transports, or if you've got your own, if you built your own transport plugin, okay? And we do have examples that you can get from a GitHub on transport plugins. You could follow that example, but usually customers will engage RTI with some extra help, so we can help you build a transport for what you need. But to do that, to install that, you would use the property QosPolicy for the domain participant. And here's an example where we're going to configure the participant to load the TCP v4 transport plugin. So you set a property, and property is a name value pair, and you can set different properties, and there are specific properties that are related to the transport plugin. And this is an example of configuring the property QoS to tell a participant to load the TCP v4 transport plugin. One of the common things that you will do for built-in, as well as perhaps some of the loaded transports, is selecting the network interface that you want to use. 10 or 20 years ago, most computers perhaps only had one network interface per network card. And if you might have multiple network cards, and each network card has a network interface. But nowadays you have virtual network interfaces. You may be running virtual machines on your system. You may be running VPN on your system, on your host, and therefore it's not uncommon to see 8, 9, 10, 12 network interfaces who may or may not all be connected up and running when you do an IP config or IF config, which will show you all the network interfaces. So by default, if you don't do any configuration, the UDP transport plugin or the TCP transport plugin will use all the network interfaces that show as up and running. Okay, so the transport plugin will ask the operating system when you start up a participant, hey, what are all the network interfaces that are up and running? And by default, they'll use all of them. Okay, so this may be what you want, because this will allow your application to talk over all the different networks that your computer is connected to. Maybe that's what you need. However, most of the time that isn't what you need. There may be only a few networks that you want a particular application to talk over, using. So what you need to do is restrict which network interfaces are used. And the way you restrict it, again, is through a property, a QoS that you can set. And we'll show you the XML configuration here. So you could also do this in code if you wanted to, but I'm showing you the easier way when you're using an XML file to configure the QoS. So there's a DDS transport UDP4 built-in property for the UDP-v4 transport plugin, and it's allow interfaces. So here you give a comma separated list of the IP addresses or a pattern. It does allow you to use some wildcards to tell DDS which of the network interfaces, what addresses are allowed to be used. Again, these should be addresses that are mapped to the local host on which you're running your application. There's also a deny interfaces list. So you could either set the allow interface or you could set the deny interface, or you could set both. And basically, if it's allowed, we'll allow it. If it's denied, we'll deny it. Even if something is allowed, but you put it on the deny interface, it will be denied. Okay, so hopefully it's fairly logical of what's going to happen. But fundamentally, if it's allow interfaces, if you set the allow interfaces, then any interface that's not on the allowed list will be denied. If any interface that's allowed but shows up on the denied interfaces list, then that interface cannot be used and will not be used. So there's also the transport unicast and transport multicast QoS policies. What this does, it configures the domain participant. It's basically you're setting an address for the domain participant. Okay, the previous policy tells the transport plugin which interfaces you're telling it what interfaces you're allowed to use. But what the transport unicast and transport multicast QoS policies does is it tells the domain participant what's your address. Okay, so when a domain participant contacts another domain participant, the first thing it exchanges is, hey, where do you live and where do I live? So I'm going to tell you where I live, my addresses, and you tell me your addresses. So when I contact you, I'll send data to your address, and when you contact me, I'll send the data to my address. Except in this case, for domain participants, it can be multiple addresses on multiple transports. The transport unicast and transport multicast QoS policies will configure a domain participant to use some specific addresses, either multicast or unicast, to tell the other side, hey, this is how you contact me. Of course, by default, we'll just use everything that's been enabled. And by default, we will not use multicast. So you actually have to configure multicast. So by default, a domain participant will use the same transports to receive data for all data readers. So basically, like the domain participant has one big mailbox, and that mailbox has an address. So everyone will just send data to that mailbox, or one mailbox per IP address. Now, on the other hand, if you want to, you can say, no, for this data reader, I want the data to be received in a different mailbox. Okay, and different mailbox or different sockets are actually processed by different threads. All the data coming into a socket will be processed first in, first out order with a single thread. So if you want a data reader to be processed by its own thread, then you're going to have to use the transport unicast or transport multicast, depending on how you want the data to be sent, a QoS policy to set a non-default value. By setting a non-default value, we'll create a socket specifically for that non-default value. And for transports, it's usually a port. For IP-based transports, it's a port. You could also assign it to a specific transport plugin. Say you want data for this data reader to be only received over shared memory, and this data to be only received via TCP. Then you could assign data readers to different transports or different ports on existing transports. These are highly configurable if you want something different than default. By default, you don't have to do anything, and DDS will just receive all the data on every transport that it's enabled to use. And multicast is the same way. You can configure Connext DDS to receive data via multicast for a data reader. Now, transport plugin QoS use cases. When would you use transport plugin? When would you modify the transport plugin or transport plugin QoS? Well, in systems that you have high availability, you're probably going to have multiple networks and perhaps even multiple transports. Okay, and you might want to use them at the same time so that if one particular network fails, you're still getting data from the other one. Sometimes you actually want to augment your system. So maybe the bandwidth over one transport is insufficient. So some of your data needs to come over this transport, some of your data needs to go over another transport. Sometimes you want to prioritize your data delivery. So maybe you have a really fast transport and maybe you have a slower transport. Maybe one transport or one network is a secure network and the other one is an insecure network, and you need to differentiate between them, and you need to tell GDS, this data should only go over this network and that data should go over that network. Okay, and maybe you want to dedicate sockets and threads to a specific topic. So these are all different reasons that you may need to use the transport QoS policies, and as well as the different transport plugins to tell GDS exactly what you want it to do with data. So in summary, Connext DDS has a transport plugin architecture, which it uses to connect to communication interfaces. And communication interfaces are not just IP interfaces. They could be shared memory interfaces. They could be actually anything that you want to write. Okay, so the built-in transport include transports over UDP v4 and UDP v6 and shared memory. But RTI also offers TCP, real-time WAN, and limited bandwidth plugins, and these are optional products, and we do have training on those as well. You can develop your own transport plugins. There are examples if you search for them from GitHub. And then QoS policies are used to configure these transport plugins, as well as configure GDS how to use or which ones to use. Buffer sizes, network interfaces, which topics go over which transports, so on and so forth.